Hi, math friends. Let's check out our systems of equations study guide together. Now, this was a tough skill because it's taking into account so many things that we know. The big thing for us is these break-even points because that is actually what we're trying to solve for each of them. Now, the idea of the break-even point here, the cost of producing earrings is $470 at the break-even point. What is the amount of income from selling earrings at the break-even point? So the cost of producing. So we have spent $470 at the break-even point. Okay. Now the question is, how much do we have to make to break even? That's really what the question is. So our income needs to be the same because our break even should be when these subtract to get 0. So it's really the same amount, $470. All right, considering this system, we're going to identify the slope and y-intercept. So remember, if we have y equals mx plus b, we are set up for success with these equations. mx plus b, m is 2. b is 0, negative 4. Okay, also remember sometimes the slope we think of as 2 over 1, and we'll do that on the graph. Over here, this one's a little tricky. In front of the x here, there's a negative. Remember, it's negative 1. So negative 1, my b is 0, 5. Okay. Based on my answer for part A, what's going to happen here? Do we have intersecting, the same line, or parallel lines? Well, if they're the same line, they would be the same. So they're not the same. If they were parallel, right, meaning they don't cross, like kind of like this, okay, they would have the same slope in different intercepts. These slopes are not the same. So it's got to be intersecting. Okay. Now we're going to explain that just with that. We're going to say they have different slopes. How many solutions does the system have? Well, since they intersect, they have 1. How can you tell? Really the same reasoning. They have different slopes. So we're going to see this on the graph. You could definitely graph it and then come back and answer the questions too. And we're going to do that for the next one here too. I'm going to write these down again. Y equals 2x minus 4. And y equals negative x plus 5. Okay, so our slope here, 2, so 2 over 1, up 2, right 1. Our intercept was 0, negative 4. Start at negative 4, up 2, right 1, up 2, right 1, up 2, right 1. Now, when you do this digitally, it can make the line for you. But when we do this on paper, something to this, right? Use that ruler, protractor, any sort of straight edge you have, right? You've seen me use the edge of like a cardboard or something when I'm just looking for something. Over here, negative 1 over 1, down, right, 0, 5. Start at 0, 5, down 1, right 1. Keep following that pattern. Ooh, and we saw that point of intersection right there. So our solution is where they intersect. Okay, right here, that's our solution. And that is 3, 2. So we also verified different slopes, 1 point of intersection, 1 solution. Let's try this one, and we'll do the opposite way. We'll graph it first. So identify the slope and intercept. Well, slope is right there, 1/2. Intercept is right there. That's 0, negative 1. Again, slope is right there, 1/2. Intercept is 3. Let's plot this first, and then we'll come back to the questions about it. Okay? So I have y equals 1/2 x minus 1. Y equals 1/2 x plus 3. I want to make sure that I wrote that right, and I did. Okay. So this minus 1, start here. And then remember, 1/2 is going to go up and right. So up 1, right 2. Up 1, right 2. I can reverse it. Down 1, left 2. Down 1, left 2. Draw my line through. We got really good at these in our previous unit about plotting lines. Let's try this next one. up 1, right 2, 0, 3. 0, 3, up 1, right 2, up 1, right 2, down 1, left 2, down 1, left 2. Now, when you look at these lines, you might just kind of know it by looking at them. These are not intersecting, and they look like they will never intersect, right? If my lines were like this and this, I could say, oh, these two lines will intersect, right? But that's not how this looks. These will never intersect. These are parallel. So we have no solution. Okay, so now let's go back and we'll think about this as we answer the questions. Okay, so they are parallel lines. Okay, so how do we know that based on the equations? Well, they have the same slope and different y-intercepts. If they had the same y-intercept, they'd be the same line too, right? But same slope, different y-intercept, they're parallel. We see that on the graph. Do the graph first if that helps you. How many solutions does it have? We already graphed it, we know. No solution. How can you tell that? We can say we have parallel lines. Okay, you could also say something here about the same slope, different intercept. We have parallel lines. They will never intersect, something like that. All right, let's check out this next one. This next one's a little bit tricky. Okay, so I have 2y equals 4x plus 6 and y equals x plus 3. Do these look like y equals mx plus b? Say it out loud while you're listening. You're right, one of them does, but the other one, no. So we got to do something tricky here. 2y equals 4x plus 6. Now, I want it to just be y, not 2y. Like this, not this. So I'm going to divide this whole thing by 2. When I do that, I'm going to divide here. 2 divided by 2, I get y. 4x divided by 2, 4 divided by 2 is 2, so 4x divided by 2 is 2x. Positive 6 divided by 2 is positive 3. This is the equation that I'll use for part A. Slope 2, intercept 0, 3. This one, easy. 1, and then intercept 0, 3. Let's plot it, and then we'll do the questions. Okay, so y equals 2x plus 3. And then I also got y equals negative x plus 3. So remember, this is 2 over 1, up and right. Start at 3, up 2, right 1, down 2, left 1, down 2, left 1, down 2, left 1, down 2, left 1. We filled up that whole graph there. Pretty cool. Remember, draw your line all the way through. For our second equation, start at 3, and our slope is negative 1, so I go down 1, right 1. Can we write that properly over here? Or did I make a mistake? Oh, it is positive 1. I rewrote this wrong. So let's correct that. Y equals x plus 3. So this is a slope of 1 over 1, up and right. Start at 3, up 1, right 1, up 1, right 1, down left, down left, down left. And we're going to see they only cross once, and it's right on the y-axis. Okay? So they cross right here. Our solution is 0, 3. So now we can go back to the questions, right? These are intersecting lines. Explain our reasoning. They have the same slope. They have different slopes. How many solutions? It has one solution. How can you tell? We can say the same thing. They have different slopes. So we know that before we graph it, but we already graphed it just to make sure. All right, number 5. This is probably the trickiest one here. All these parts of number 5, solving these equations. We have to remember all these steps. So I've got negative c equals 10 minus 3c. So I'm going to add 3c So remember, this is negative 1. So this is 2c 10. Divide 2, I get c equals 5. Okay, these are those straight up solving the equations. All right, over here, part B, 5 parentheses 2x minus 1 over 3 equals negative 2. So we got some work to do, right? We're going to distribute a bit. 5 times 2x, 10x. 5 times negative 1, negative 5. So we got over 3 equals negative 2. Now here's a little trick. This is being divided by 3. So I can go ahead and actually multiply this by 3. Multiply this by 3. When you do, since everything's being divided by 3, we can cross it out. Those divide out. I get 10x minus 5 equals negative 2 times 3 is negative 6. Now I can do inverses like I'm used to. Add 5. So I get negative 1. I get 10x. I'm going to rewrite this up here. 10x equals negative 1. Divide the coefficient. So I get x equals negative 1 over 10. All right, let's check out 5c here. So we've got this expression divided by 4. We've got a lot going on here, complicated. So what we got to do is line down the equal sign, separate both sides first, right? Keep everything structured. That's going to help you. I'm going to distribute negative 8 times x, negative 8 times 1. So I've got negative 8x minus 8. I've still got this over 4, and I've got to distribute over here as well. 2 times 2x is 4x. 2 times 10 is 20. This 1/4 is on the end. Now, I'm going to think of 1/4 as, here's my thinking step, 1 divided by 4. That's the same as 0.25. So I can go ahead and make that 0.25. So I'm going to do 4x plus 20.25. That might just make things a little easier to compute. Okay. Over here, everything's being divided by 4 on the left side. So I'm going to divide by 4, negative 2x minus 2. All right, let's keep going with that. I'll move these x's over here, minus 4x, minus 4x. So I've got negative 6x minus 2 equals 20.25. Remove the minus 2 by doing plus. So I've got 22.25. That zeroes out. I have negative 6x. Our last step, you guessed it, is to divide. Divide by negative 6. Now I'm going to write this final answer over here because I ran out of room. So I've got x equals 22.25 divided by negative 6. So I've got negative 3.7083 repeating. Realistically, we usually ask for you to round to the hundredths place. So that would be this. But, you know, we're going to be okay if you type out this whole thing or writing this whole thing too. That's fine. That's your exact answer, all right? I'm going to look at my x's first, my variables. So get rid of this. Add 1/2 x. Add 1/2 x. This is going to make your life so much easier. Also, this 1/5, I'm going to think about this. 1 divided by 5 is 0.2. So really, 4 1/5 is 4.2. Okay? Add 1/2, I get 4 halves x. 4 halves, what's 4 divided by 2? 4 divided by 2 is 2. So this becomes 2x. Now I can divide. X equals 2.1. All right, number 6 here. This one we have to determine if there's one solution, no solution, or infinite. Now, way to do this is to straight up solve these. So let's go about them. 3 times 2x, 6x. 3 times 11, 33. Minus x stays there. This does not, this is not in the parentheses, right? This 11, same thing. It's outside of this term. 2 times x, 2x. 2 times 11, 22, plus 3x. Combiner-like terms only on each side, right? So 6x minus x, I get 5x, I get a 33. Try this side now. 11 and 22 is 33. 2x and 3x is positive 5x. Okay? Now we're going to move our x's, so subtract a 5x because I want to move them over here. Okay? That makes 0, that makes 0. I drop down 33. I drop down 33. At this point, there's no variables. Does 33 equal 33? Okay? If you said yes, you are correct. So this means I have an infinite number of solutions. Okay, that's a toughie. Part B. Little tough too, but same idea. Look at my right side. There's nothing to simplify here. The left side has a lot to simplify. So I'm going to rewrite this. Take that win, right? Over here. Let's go ahead and multiply. 5x. I got a minus here, so minus 5. I got a negative here. This is tricky. It's like a negative 1 we distribute. Negative 1 times x is negative x. Negative 1 times 2 is negative 2. Now we combine our like terms. 5x minus x is 4x. Negative 5 minus 2 is negative 7. Other side, 4x plus 10. At this point, you might see what your answer is, but I'm going to go one step further just so we make sure we see it. Remove the x's. Minus 4x. I'm going to do that to the other side. 4x minus 4x is nothing. Drop this down. Negative 7 and 10. Now we ask ourselves, does negative 7 equal 10? There's no more variable here. The answer is no. So here, there is no solution. All right, number 7 is a little bit tricky where we have to write our system of equations, but it's really not too bad. This says admission to a zoo costs $12 for adults and $8 for children. A group of 25 people paid $228. Write a system of equations to represent the situation. Let A represent the number of adults and C represent the number of children. All right? So when I'm looking at this, important thing for me to think of is A is the number of adults plus the number of children equals 25 people. Okay? Now I've also got the cost. $12 for adults, $8 for children, and the total cost is $228. Here's my system. That's it. Write my system, done. Solving the system. This is where it's a little complicated. I'm going to start with my first one, and I'm going to solve for A. So minus C. So I get A equals 25 minus C. Now I'm going to substitute that in to my second equation. So I've got 12 parentheses 25 minus C plus 8C equals 228. Okay, so now I got to do some work here with distributing. So 12 times 25 is 300. 12 times negative C is negative 12C. Remember that negative there. That's a little tricky sometimes. Plus 8C hangs out on the end. 228. Combine like terms. 300. Negative 12 plus 8 is negative 4C. Now we solve. Do our inverse is minus 300. I get negative 72. I get negative 4. C divided by negative 4. I get C is 18. So my number of children is 18. And then I got to find out the adults. So A equals 25 minus, instead of C, use 18. A equals 7. So we have 7 adults and 18 children. Okay. Our very last one. This one might be one of the easier ones here. And I say easier, it's not that it's easy, but it says consider the system of linear equations below. Determine if each of the coordinate pairs is a solution to the system. Okay? So to see if this is a solution, we have to plug in this ordered pair to each one. So I'm going to go 3, instead of x, use 0. 6, instead of x, use 2. Does that equal 12? Let's find out. 0, I'll line down the equal sign, plus 6 times 2 is 12. 0 plus 12, yes, that works. Let's try the other one too, because it has to work for both. So 0 is x, plus 2, instead of y, we're going to use 2, equals 4. I wrote that wrong. Okay, 2 times 2 is 4. 4. Does 4 equal 4? Yes. So my answer for this one is yes. Be excited about it! Exclamation point. Okay, 4, 1. Let's see if that works. 3 times 4 plus 6 times 1. So we're using that first equation again. Does that equal 12? 12 plus 6, does that equal 12? The answer is no. That's 18. 18 is not 12. So my answer for this one is no. That didn't work. This one did work. Let's check the final one. Yeah, once it doesn't work for one equation, we don't have to keep disproving it. Let's do 3. X is 3 this time. Y is 3 this time. 9 plus 18, does that equal 12? 9 plus 18 is 27. 27 does not equal 12. No. Oh no, that doesn't work. Okay, we got to show the work. We got to do our best. Okay, always give yourself a chance. You got this.